In this video, we're going to take a quick look at an example using the intermediate value theorem. Okay. Now, the intermediate value theorem is the theorem that is used to check for at least one real zero for an x value. What I'm saying is, if I have these two x values, what we're looking at is graph cross the x-axis at that point. Okay. So the best way to explain the intermediate value theorem is just to go ahead and work the example here. So in this case, we're going to use that intermediate value theorem to determine, if possible, the function has at least one real zero between a and b. So we're given a function, and then we're given an a and a b. And so what we're looking for is we're looking to see if we can state a conclusion. So the way it works is we would first look at, say, p of a, and in this case we're told a is 1. So that means anywhere we have an x, we're going to plug in a 1. So this is 1 cubed plus 3 times 1 squared minus 9 times 1 minus 13. So you're going to go ahead and reduce that, and in this case you should come out with negative 18. And then the second thing we're going to look at is p of b, and in this case b is 2. So we're going to do the exact same thing, except anywhere we had an x, we're going to plug in a 2. So this is 9 times 2 minus 13. And in this case we end up with negative 11. Now, notice both of these signs are exactly the same. Because they're the same, what this tells us is that we have no conclusion. Since the signs are the same, you cannot tell if you have a zero between them or not. Okay? The only way to tell if you have a zero is that your sign of p of a must be opposite the sign of p of b in order to conclude that you have a zero. If your signs are the same, then you cannot make any such conclusion. And that's really all there is to the intermediate value theorem. There's nothing more to it other than that. So if you have any questions here, please let me know. This theorem can be a little bit confusing in the beginning, but practice, the more practice you do with it, the easier it becomes. But it really just is that simple. You're going to plug in your value for a, and you're looking at the sign that you got. You're going to plug in your value for b and look at its sign. And again, one more time, if the signs are the same, you cannot draw a conclusion. If the signs are opposite, then you can conclude that you might have a zero at that between those two values. Alright, so if you don't have any questions, I do hope you enjoyed yourself, and I look forward to speaking with you next time.